Thank you very much, Ian, for those very kind words. Thank you to IABSE, and of course, thank you to the institution for hosting me this evening. The subtitle to my talk should probably be How to Lose Friends and Alienate People. For the last 20 or so years, I've been taunted with this quote by friends of mine from university. It's fair to say that they don't all share my passion for bridge design. However, what those friends typically don't mention, however, is the second half of the quote, which is the punchline. Worry about the problem and you'll find the solution. It's a great quote and a valuable provocation for any designer. The quotation's from this gentleman in the bottom left-hand corner called Cedric Price. I'll come to him in a moment. In a way, it's just unfortunate that bridge design is used as the basis for this metaphor, because I find that bridge designers, whether from an engineering or an architectural background, I couldn't care less, to be problem solvers first and foremost. In other words, we're all very concerned indeed how to get to the other side. Brief segue, this is the hockey stick. I was in my RIBA Part 1, so my undergraduate, when this graph was produced, and it needs no introduction. Global temperature variation or anomaly on the vertical axis there, plus or minus 1 degree for the last millennia. Now, of course, the implications of what this describes are so much more profound than a change in temperature. And I'd say that this is the defining image of our generation professionally, and the context within which all of us as designers are now operating. Back to Cedric Price. Now, he's been called the most important architect that you've never heard of. He was a teacher and a provocateur, raconteur, bon viveur, all of those things. He taught at the Architectural Association, I believe, here in London, and through his largely unbuilt work, he was nevertheless a colossal influence on the course of late 20th century architecture, especially the work of the high-tech knights. So think of Foster, Rogers, and so on. Think of the Pompidou by Rogers in Paris. There's a straight line from the Fun Palace, which was a conceptual project by Cedric Price, straight to, like I say, the Pompidou Centre. Now, from a very limited pool, his most famous built work is the Snowdon Aviary at London Zoo, which is on the screen here. Named for the client sponsor, Lord Snowdon, it was designed by Price with Frank Newby, an extraordinary designer himself, well known to this audience, I'm sure, and certainly to this institution. The aviary employs principles of tensegrity, much like Newby's earlier Skylon at the Festival of Britain, but in this case, to provide a suspended framework of 4 tetrahedrons that then create this kind of enclosure wrapped in mesh. I find the economy of this structure to be beautiful. There's a reductive approach to material here, and it's a direct response to a functional brief. In that sense, it is not dissimilar to bridge design, and I expect Price knew it. So the key is economy, and this is how I'd like to discuss the work of my practice. It pretty much goes unsaid in our studio, whether in London or in Scotland, but when I look around the work that we're doing collectively and as individual designers, I'd say that economy is the common thread. It's not about parsimony and it's not about expediency. It's about efficiency, it's about leanness, and when it's at its best, it's about elegance. And I'd say that we've learned this culture from bridge design. I'm going to describe this culture in 3 strands. First of all, economy of material. Now, this speaks for itself, and it's pretty much axiomatic to everything that we do as bridge designers. Secondly, economy of action. Now, this is a bit more cryptic, and it's probably more relevant to the architects amongst us. Put crudely, as bridge designers, we all pick our battles. We need to be conscious of and target those aspects of a design that can elevate the functional to the beautiful. It's about prioritizing our approach, and this is probably the hardest aspect of the work that we do. But I believe economy of action is what separates the very best bridges from all the rest. Thirdly, and finally, economy of purpose. Now, economy of purpose can relate to the detail. All of us in this room know the satisfaction when a design achieves several things at once. 2 birds with 1 stone. A parapet that is the primary structure, a deck that's also a belvedere, and so on. Now, as a designer, one of the truly wonderful things about bridges is their instrumentality. They cross a gap. they solve a problem. Now, of course, they may solve a number of problems, but in their instrumentality, they are closer to industrial design, I would say, than the design of buildings is. Now, this leads me to my first project, and it's not a bridge, although it was designed with crucial input from Paul Sanders at Covey several years ago now. Now, this glorious photo is by Tim Saw. It's one of our Royal Park's drinking fountains. They've since been installed in several of London's royal parks. It was won in an open international competition, and it's the first of two examples of bridge design, industrial design rather, that I'll share tonight, and it neatly encapsulates economy of purpose. It does the thing it's supposed to do, which is deliver clean, safe drinking water to all manner of users. K9 at the far end there. There's a dog bowl at the base, which acts as an overflow, and it's also the trap. So if someone drops their wedding ring in the top, it will appear at the bottom for safe retrieval. It also functions as a bollard. Now, these drawings are from the early competition iteration. The form and the connection at the base developed and was significantly refined, in fact, not least with Paul's input after we won the competition. And here you can see more of the refinement going on. As you can see, it's a singular form that provides the mounting for the faucet at the top of the screen, a bowl for splashes, the drain, a sleeved connection to the base assembly. The design is what I'd call tap agnostic. You can mount pretty much any outdoor tap on the market to the fountain. Now, this is important to us and our approach to design. It's essentially open source, if you like. It's designed for long-term flexibility. And incidentally, that's another lesson that we've taken from the philosophy of Cedric Price. Now, of course, we also have a fascination with material quality and aesthetics. We wouldn't be architects if we didn't. The drain cover is a kind of a kidney bean or a meniscus of stainless steel. And this is because visible cleanliness is important to any design where consumption is involved. This was also one of our first forays into rapid prototyping. It's now obviously commonplace in everything that we do. In this case, this little model was proof of concept that the various bits of this assembly fitted together. And here's the actual size, finalized geometry, which was milled on a 5-axis router, which was very unusual at the time. It's now, like I say, it's commonplace. Now, that formed the master part for the creation of wax-lost sand moulds at Castle Bronze Foundry in North Wales, which resulted in just the most gorgeous work when it came out of the casting. Obviously, it was then all polished up for installation in the parks. This is our very first customer, the daughter of one of our clients at the Royal Parks. And of course, the bronze over time patinates, which then in turn accentuates the brightness and the cleanliness of the kind of the hygienic parts, so the tap and the drain. But it also lets the fountain take its place alongside street furniture of all eras, really, in London's parks. Here outside Kensington Palace, I think there's 3 or 4 in Kensington Gardens and Hyde Park. Clearly a dog has been at the bowl just before this photo was taken. So my first bridge of the evening, which is also one of our most recently completed structures. It works, very good. This is the Duke's Meadow footbridge in Chiswick, West London, which we designed with Covey, and Cameron's in the audience, so I should name check him. He was in charge, I think, on the Covey side. Now, this bridge doesn't cross the Thames as such. It runs parallel to the riverbank, as you can see, fixing a hitherto broken section of the Thames path. In fact, this is the second of our bridges to do this after the Greenwich Reach Bridge, also designed with Covey and David all those years ago. Now, in this instance, the parapet is the primary structure. This allows us to thread the needle between the tidal range of the Thames, which you can see here at quite high tide, and the narrow headroom that we have beneath the existing Barnes Bridge. It's the plan form. Now, economy of purpose is also achieved through the subtle flexing, what we call subtle flexing of the geometry at the corners of the structure. It's a really lovely worm eye axisymmetric, or fish eye, if you like. just where we go beneath the existing bridge, you can see how it's very subtle. The geometry of the deck widens at those points. So it's a local increase in width. And this is simply to enable the congregation of people at those 2 points, looking up and down the river, giving a completely new view, wonderful new view, in fact, of the city, but also more particularly a great spectator viewpoint for the Oxford and Cambridge boat race each year. That's not the race, these are just recreational rowers, as you can see. Now, I mentioned the coincidence of structure and parapet. And this is something we've explored on several recent bridges, and you'll see some of them this evening. But here it means that the individual spans are discrete. They're connected at the piers, of course, but they're fabricated and installed simply as independent components. Each one brought up the Thames from Tilbury docks before being floated across the piers and lowered on the receding tide. In other words, let nature do the work. Now, of course, it's not quite as simple as that. The installation relied on gravity, but also the Chris Murphy 3-part locator pin. I don't think Chris is in the audience this evening, which is a shame, but his pin is somewhere in this photograph. Now, bridge design is full of these innovations, and they always come from economy. They're always about achieving efficiency, making more with less. And in this case, free lifting and lowering capacity of the tide has been enabled by Chris's ingenious design that ensured absolutely pinpoint accuracy as this thing was dropped onto its piers as the water went out. Not a lot of people know that, and certainly none of the users each day, but it would have been quite a different bridge without it. Now, our next bridge does legitimately go from one side of something to another. In this case, Royal Victoria Dock in East London. In fact, as an aside, another joy in what we do comes through the way in which we use drawings to explore geometry. So how geometry can solve a problem. And this is very particular to bridges, much more so than buildings and more so than industrial design as well. I think bridges are almost, they're not unique, but it's a very special aspect of them. This is a drawing where we're looking at the plan alignment of this particular structure alongside Simon Fryer and his team at Bureau Happold. It's about probing the geometry in pursuit of solving the problem. So a bit more on that now. You can see XL Centre at the top, Royal Victoria Dock in the middle, and then there's the new Silvertown redevelopment by Lend-Lease at the bottom of the image. You also, I'm sure everyone in the room will recognise the existing bridge at high level, which is just left of centre there, the delicious Davidson Royal Victoria Dock Bridge. Now the black line connects our A to B, but at a lower level than the existing, because this new bridge must cater for a vastly increased footfall once Silvertown is developed and in use. The dotted line in the middle represents an opening section of the bridge where we must provide unlimited vertical clearance for tall ships and so on. The constraint on the left-hand side of the dock is provided by the existing bridge, not ours. Now, straight line is obviously the shortest line, but in this case, we might make use of an existing structure, this kind of pontoon thing at the bottom, to shorten our bridge. We could flex the alignment to orient people directly into the heart of the development at the bottom. But notice that the dotted part of this diagram, which is the opening section, is starting to get very long. Very long and moving equals expensive and more energy intensive. So normal to the channel, or more normal to the channel, shortens the opening parts, but here it lengthens the overall structure. Likewise. And again, shorter opening span, but overall still much longer. Maybe we can make use of the dock again, although it's a longer route overall, less intuitive for users. Now we're starting to get somewhere. Shortest opening span, and it delivers users where they want to get to. And there's the sweet spot. So comparatively short opening span, comparatively direct route, plenty of modularity and replication in the curves and spans. And here it is. So Newham Council granted planning permission on Tuesday night this week for this structure. Unanimous decision by committee, and we're straight into detailed design. Apparently the bridge needs to be open in 2025. The opening span was designed with Eden Consulting, of course. Who else? The top surface is uninterrupted when closed. It's a stealth opening bridge in that sense. It's about a consistent urban experience for users, with the element of surprise and delight when boats do indeed need to pass through the dock. There's joy in the detail, of course, embracing the difference between one span, the static spans, and the moving span. The actuators for the bascule are integrated into this pier design. The bridge is part machine, and the design does not try to hide this at all. So there's another view. We can see the S-curving trajectory of the deck across the dock, backspan with this V pier in the foreground. Now there is a vertical curve in addition to the opening span, such that smaller crafts can just pass beneath. This means that the deck edge and the soffit is therefore visible from the quayside. So the consistency of the structure, including that opening span, is very important to us. It's relatively efficient, and you have this appealing snake-like form beneath what is an otherwise urbane and civilized public route. So it's the top surface is a continuation of the public realm that's being designed for Silvertown as a whole. So economy of purpose therefore comes from the reconciliation of the competing demands of the opening span and the overall alignment of the bridge, but also the urbane topside with a structurally responsible but still expressive kind of undercarriage beneath it all. And just briefly on another opening bridge, and this is another structure with Covey, this time at Port of Dublin, which is in the midst, as I'm sure you all know, of a post-Brexit boom, with a huge expansion underway as a result of the increase in direct transfer of goods from the EU to Ireland, which is unfortunate, but positive for us in the sense that this new bridge will service that boom, permitting lorry traffic to cross the Liffey near the harbour mouth, whilst maintaining access for river traffic. It's another bascule, this time with a counterweight over the carriageway. Here it is fully opened. Now, the sharp-eyed amongst you may have spotted in this and the previous slide something unusual going on with the pivots, particularly that of the counterweight arm. This gives the game away. So it's another piece of ingenious design, this time by Richard the Bridge. Speak of nominative determination. Who's in the audience, or is he? There he is. And also, of course, Eden Consulting. By bringing the pivot of the counterweight forward of the deck pivot, the counterweight is brought into maximal effect earlier in the opening process, increasing its effectiveness and therefore the efficiency of the mechanism. The mechanism also occupies a smaller footprint as a result. You can see the joy that comes from designing such a thing, making sure that the geometry all nests together and it all moves and looks sweet. Now, in the closed position, the counterweight is I feel like it's a demonstration of mass and the potential for movement or potential energy by holding this thing up in the air, a sort of portal over the roadway. We're currently exploring the use of Wicklow granite slabs as the counterweight material. Now, this does bring some complications, but there is a clear reward there if it can be made to work. But, for one thing, it would hugely reduce the embodied carbon compared to concrete or metal. Next category is economy of action. And like I said at the start, I have a hunch that this might be where there is the greatest potential for us as designers and probably architects, actually, to have the greatest impact in elevating the functional to the noteworthy or even extraordinary. First example here is actually a very ordinary structure, the Hamsway foot and cycle bridge near Worcester. As you can see from the plan at the top there, this is a pretty straightforward brief. Negotiate a busy roundabout, full stop. And the elevation at the bottom, in diagrammatic terms, this is no different really to hundreds of other similar bridges crossing England's trunk roads. Indeed, the client's brief included the stipulation that the bridge should be like other such bridges in the area. What elevates this above the norm are a series of modest but related moves in the detail of the design. Moves that respond to the setting, the use of the bridge, and frankly, the appetite on the part of the team to do something a bit special. So first, the parapets lean towards the direction of cycle traffic. This is part of National Cycle Route 46 from Worcester to the Malvern Hills. And this subtle shift, very simple shift, alters your perception of the structure when you come onto it. It introduces some craft and a kind of graphic intrigue when you look along it, and also particularly when you look across it, as you can see in this image. The approach spans couldn't be more simple. You can see on the left-hand side there. While on the right, the main span is an arched truss. To unify them, however, you can see that the outer edge beam and the members of the truss are all rotated approximately 45 degrees. Now, this simple move captures the light, reducing the apparent weight of the structure, and again bringing that craft sensibility that takes us away from its rather dull and quotidian peers. P-E-E-R-S. And this detail, I absolutely love this detail. Where the approaches meet the main span, the two chords bend away from one another, separating the vertical support of the approaches and expressing the main span as a closed and separate element. So it's a modest and simple bridge, but I'd argue that these moves make it something a little bit special nevertheless. And happily, the same team with Ben Curry and colleagues at Covey, we're now working on another bridge in Worcestershire, this time across the River Avon. And well, we have some hope that we might be able to talk to David about the fabrication of this structure in the future as well. The entirely opposite end of the spectrum in terms of scale, I'd like to talk about 3 of our viaducts for HS2. We're part of the Eiffage Kier Ferrovial BAM team. We are sub-consultants to Arcadis Cedric Covey. We are a very, very small cog in this gigantic machine. But it's to great credit of our client, or clients, so Arcadis Cedric Covey, but also Eiffage Kier Ferrovial and BAM, that the role of a small practice such as ourselves is given a voice and can contribute to the discussion of what needs to be landscape appropriate design. Now, I often think, Ian, of your formulation in your TED talk, that a badly designed and executed bridge is nothing short of an act of vandalism on the landscape. And I think that's brilliantly put, and I've had those words ringing in my head whenever I've thought about these structures, particularly the first 2 that I'm going to show you, which are located in the Chilterns area of outstanding natural beauty. Now, this is a kind of an elevation map, if you like, of the Chiltern Escarpment, which you can see very clearly diagonally here on the right-hand side, with the great flat expanse of the Aylesbury Plain on the left. Importantly, you can see the valleys that cut through the Chiltern Escarpment, cut through the wall of the hills there. And one of these is the Missenden Valley, which cuts through the escarpment at Wendover, just the centre bottom of the screen. Now, this geographic feature is known appropriately as the Wendover Gap. And you can see a road, a railway running through this gap. It's been the main line of communication north-south through this part of the Chilterns for thousands of years. You've got road, railway, national grid, high voltage lines, public rights of way, everything follows this line through this landscape. So it's no accident that HS2 is also following this line. The first of our viaducts that I'm going to talk about is at Wendover Dean, which is just to the south of this gap. You can see in this image, the viaduct is the kind of the solid line in the centre of the frame. And you can see the parallel lines of communication off to the left and a couple off to the right as well. Everything follows this valley. Now, what's interesting about this site is that the terrain is such that the views of the viaduct will almost always be backgrounded by terrain. So you can see the grey patch on the right-hand side, the line that marks the boundary of it is at the same contour, same height above sea level as the centre line of the deck of the structure. So you can instantly see that if you're on the left-hand side, you're going to be looking at this thing against the hillside, or if you're on the right-hand side, you're going to be looking down on it again against the landscape. Now I'm giving the game away again by showing the structure before I talk about the design. But you can see here that much like the Hams Way cycle bridge, it's apparently very simple design. Below deck structure here in weathering steel. What are those piers about? That's certainly unusual. Again, in all of the views, apart from when you get very close to the structure, you can see that the viaduct is backgrounded by the landscape. Now, during the petitioning stage, the Campaign for the Protection of Rural England stated that, separate to the acknowledged icon of Colne Valley, the detailed design of Wendover would be a litmus test for the quality of design of HS2 Phase 1 in general. So no pressure. So bearing that in mind, and of course Ian's TED talk, the first thing to do is pull the overall form of this viaduct into shape, respond to the landscape. This is the reference design. Now it works, and it had its uses in terms of the progress of the bill through Parliament, but what a lopsided appearance. Bring some symmetry, ensure that the space below the deck is balanced and the air draft beneath the structure is greater than the beam depth. Simple things. Shortening the structure at one end reduces the cost, obviously. And even better, if we can replace that wall with embankment, we can reduce the embodied carbon even further. We also look to eliminate all of the clutter at the abutments. So we bury the ends of the structure into the earthwork, so the viaduct springs from sockets in the landscape rather than frontal walls imposed upon it. The access stairways are then all corralled into one place with a single central access up the apron. And then within the bearing chamber, that's where we also have our access up onto the trace and for evacuation from the viaduct. You can see here that the noise barriers and the parapet all sleeve into one another. It gives you this balanced silhouette, which suits the near symmetrical ground profile from north to south. There's those piers again. The field pattern is reinstated beneath the structure, so it flows uninterrupted. And then we integrate balancing ponds and all the kind of other paraphernalia around the structure. And then again, at the south abutment, we have that same kind of socket detail. So it's kept as simple as possible. So about those piers, see Gerard's in the audience. These two slides, I don't know if you recall a discussion on this. Here's an early iteration of the design, and you can see that at this point we're actually quite proud of our piers. You can't really see it in this image, but the hammerheads will flow very nicely down into the narrow stem. We have the weathering steel, which again, this image doesn't show it, but that sits very nicely against the rural landscape. Typically, you're seeing this, like I say, against fields and trees and what have you. It all starts to blend, it all starts to work. But then we did this. Now, bearing in mind that this viaduct will overwhelmingly be seen in elevation, by projecting the pier heads upwards past the bearings, we achieve several things. We imply a connection visually between the pier and the parapet, which further recesses the beam, accentuating the brighter and more slender aspects of the design. It also masks the bearings. Piers also appear to sort of clasp the deck. And they both, well, they align with the stiffeners above the bearings. And there's also a kind of an anthropomorphic quality to the way in which this thing sort of springs out the ground and then grabs the structure. But they perform no structural function whatsoever. But I'd say that this detail is therefore similar in spirit to the radiused ends of Hamsway footbridge. There's a small shift in the detail that transforms the visual aspect of the design. And conceptually, at least to my mind, it's no different at all to the case of cable-stayed bridges, where the pylon will invariably extend upwards further than the final or topmost anchor. And only 1.5 miles north of Wendover Dean, our next viaduct is located right in the middle of the Wendover Gap. It's the confluence of all those lines of communication, the A413, Network Rail, B roads, everything all crammed into this little knot in the landscape. And now we add HS2 to this congested space. It's certainly an economic use of real estate. Now, in contrast to Wendover Dean, Small Dean Viaduct is one that the public will experience at very close quarters. You've got the A413, this main road here, and public rights of way that pass directly beneath it. So detailing becomes even more important, but also the oblique view of the structure. So where the elevation was key at Wendover, leading to the symmetry and the sockets and the piers, here at Smalldean, the skew is everything. The views along the structure are absolutely key. You can see what I mean by that skew, and also just how the structure sits across this dip in the landform. It's essentially masked from the middle distance, and almost completely hidden from the long distance. But close up, you see it all. And although it's the same structural form as Wendover Dean, it's a double composite structure, which as Paul Van Hagen will be able to talk more about that. We're dealing with substantially longer spans than at Wendover and a different set of construction priorities on the part of EKFB. Now, these outriggers were originally suggested by Eiffage Metals as a way of accelerating construction by allowing for the inclusion of permanent formwork for casting the deck on top. But of course, we seized upon them as a tremendous opportunity to do something with those oblique views. They immediately alter the appearance of the viaduct as you come along the road. And the design and coordination expresses the varying stiffening requirements. Again, this is something that Paul will be able to talk to. These stiffeners bunch above the piers, they spread out to mid-span, they kind of concertina back again. And you will see that as you drive along the road, you'll see this kind of animation to the structure. And I think this sort of infrastructural drama, if you like, that you will see will be extraordinary. I'm very much looking forward to seeing that structure on site in the coming years. Third viaduct is the next one to the north of the Chilterns AONB. It's not in the AONB, but it's nearby. This crosses the floodplain of the River Tame just to the west of Aylesbury. It's our longest and lowest viaduct on the route. Very different landform, flat as a pancake. Structure could be described as an elevated causeway. It's that low. Now, there have been more iterations of this structure than I think of any other that we've been involved with on the project, and they principally concern the disposition of the beams. So it's not our bag at all. In each iteration, however, our focus has been on the detail, the deck connection, so between the pier and the deck. So in a way, this is sort of an extreme type of economy of action. We've been focusing all our energy on this one detail. Now, the final scheme has been heavily influenced by EKFB's construction team more than anyone, and their subcontractor Pacadar. And Fernando's in the audience, so he'll be very much aware of all the detail of that. We've done something similar to Wendover Dean in that we've projected part of the pier head up. So it's again a very simple move, economy of action, like I say. But this punctuates or interrupts the face of that beam to ensure that the viaduct is seen as a sequence of spans rather than just a relentless single extrusion. And again, in an anthropomorphic way, the detail clasps the deck. Now, this is a minimalist approach, but I think it's in details like this that a pretty straightforward viaduct can succeed or fail. And like I say, this represents the economy of action. And here's that action on the ground. This photograph was taken 2 days ago as these piers have started to arrive on site. This was yesterday. And this, I'm happy to say, is today. So this was this afternoon, the first of, let me get this right, 68 piers installed on its pile cap this afternoon. And we're hugely looking forward to seeing the rest of it. What's remarkable about this structure actually is that it's one of the most recent consents that we have got. So we only got consent for it halfway through last year, and yet it's the most progressed structure on the ground. It's really sort of astonishing how lean this construction process is. Oh, I'm going to do my bit for the Scottish Tourist Board now. So I'm I'm going to talk about a couple of buildings as well. I don't know how much time I've got this evening.
Yeah.
Keep going. Well, you can always stop me or get me to hurry up. But yeah, no, quite. How do I start with this? So we have an office here in London, which most of you are aware of. We also have an office up in the Highlands of Scotland, which is where I originally grew up, and I've been working there for the last 10 years or so. And it's the most sort of incredible landscape. It's almost unbelievable that this landscape is in the British Isles, in fact. The Cairngorms National Park is the highest, most remote bit of landscape that we have in Britain. It's a fragment of the subarctic transplanted to Scotland. It combines elements of the truly sublime, and I mean that in the Victorian, terrifying sense, with kind of absurdly picturesque, verging on the chocolate box. It's an absolutely amazing place. It's where I'm very fortunate to live and spend most of my professional time these days. But what does it mean to put a building in this landscape? And I think I would say that it means exactly the same as it does to put a viaduct into the Chilterns AONB, or indeed onto the Aylesbury Plain. And our approach to buildings in general follows our approach to bridges, and not the other way around. And I think that we're probably quite an unusual architecture practice because of that. Is the kind of the clarity and the economy that I keep talking about is applied to buildings in a way that it wouldn't be if we weren't involved in bridges. I think I can say that with a great deal of confidence. This is the site of our studio in Scotland. So this is a new building which we designed a few years ago and completed in, I think it was 2020 or thereabouts, and moved into it. It's a disused quarry that's been used latterly as a tip. You can see the roadway on the left-hand side there. What's great about it, it has level access. Previously, we were shoehorned into a little building behind my house up a hill. In winter, it's an absolute nightmare having to clear the path up to it. But now we have this beautiful facility that we call home. And again, with Wendover and Smaldene and Tame, so with our building, it is a direct response to the landform. We've taken the bowl shape of the quarry, and we've essentially wrapped our building, pushed our building into it. There's various elements, in this case, concrete chimneys, which provide the kind of the hearth, if you like. Staying warm in winter is very important up there. And these become kind of the piers, if you like, that the building is then located around. Our studio, which is the big part, is sort of has its backside pushed into the bowl of the quarry. Meanwhile, we have a cafe which sits on the roadside, and that's the kind of the public face of the practice. And you can see how these volumes then are built up around that initial response to the landform. And then there's a covered walkway between those two buildings, the cafe and the studio. And then we spend a lot of time remediating the site, which you can see in this video. So the center of the site, so the building's actually quite recessive. Like I say, it backs into the bowl of the quarry, and it's all about freeing up the space in the center of the site as a garden. So although this was used as a tip, the landscape around it is all a triple SI. It's a site of it's an SAC. It's also in Scotland we don't have AONBs. We have national scenic areas. It's one of those. It's got every designation going apart from our site. We were very lucky in the sense that there was this sort of hole that we could occupy. And then in cross section, again, in terms of response to landscape, you can see if you stand in the center of the site, there's quite a big drop between the kind of the escarpment edge of the quarry and the middle of the site, and that's where we sit our building. So to conceal the scale of the building, the roof is set at the same angle, more or less, as from your eye line from the middle of the site to the top of the quarry edge, which means you don't ever perceive how big that building is until you walk into it. Another little video. So as far as the public are concerned, it's that bit at the end of the shot there that they see and experience. And it's only when people walk into the building that they actually realise just how large it is. Ian's been to the building and you can probably vouch for me on that. But it also means that we can have our own kind of private space, roof terrace here to the rear of the building, and it's just a very lovely place to work. And like I say, I think if we weren't bridge designers, it would have looked very different. Another way of looking at economy of action is embodied by another of our recent bridges. This is Esperance in King's Cross, which Ezra and Martin, who are sitting in the centre of the auditorium, were responsible for. Now, this design takes the philosophy of honing a singular part, or honing a single constituent part of the structure. In this case, the module of a single module of a Warren truss, and then repeating it. So there's economy of action there. You're looking at one part, and you're really getting into the detail, the way in which the plates are folded, bent, exactly what the welds are doing, exactly where they're going. The model which Martin and Ezra produced for this design was handed directly to SH Structures. I don't think they changed it at all, and they've fabricated it direct from the architect and engineer's model. Now, although we're, I don't know, it must be what, 30, 40 meters away from Knight Architects Bridge, the Granary Square Bridge, which is just to the east. Nevertheless, Esperance, if anyone has seen it in real life, will know that it's a very, very well-trafficked structure. And in fact, I don't think the footfall on either Knight's Bridge or our bridge has reduced since this one has gone in. I think so if anything, it's made the area busier. And thirdly and finally, kind of category would be economy of material. Like I say, this is probably the most obvious category to consider as a bridge designer. I think it's, like I say, sort of axiomatic. It's built into all of us as bridge designers, whether engineers or architects. This is a key part of, I guess, our approach and upbringing. But again, I'm going to refer to a bit of industrial design before looking at some bridges. This is this is an existing overhead line structure. I think this is the Series 2 OLES, but they're all much of a muchness. There was a competition a few years ago, run by the IABSE to design an aesthetic OLES. And we sort of took this back to sort of starting principles of what is this thing doing? And it's holding two wires, or rather it's holding a single wire, the contact wire for the train, the pantograph that supplies the power to the vehicle, and then a second wire, which is the catenary, which keeps that wire in position in the vertical and Z position. And everything else is in support of those two things. So we thought, well, this is just a question of geometry. It's just a question of shape. It's where this thing is in space, and you can define that from one mass to the next. And in particular, if we can make the component that holds all this apparatus up in the air out of an insulating material, then we are doing that thing. We're killing two birds with one stone again. So we worked on this project with Brian Duguid at Mott MacDonald. So again, it's not a bridge, but again, we're using a bridge designer, a bridge engineer as our collaborator. And you can see here how the geometry of those wires sets the geometry of our mast. We were one of 2 or 3 winners, I think it was. Martin was on the jury, so he'll be able to remember. And it's been a terrific experience actually working on this. There's our mast there. Much like the fountain, which I described as tap agnostic, our mast is componentry agnostic. So it will take all the SNCF fittings. It will take all of the fittings typically used on network rail. They can all be mounted onto our boom. There's the drawing, there's the final prototype. There's now several of these prototypes sort of dotted around Britain in various testing yards. But what it does, which is really important, is it reduces the height of this overall assembly in comparison to the existing systems. It reduces the area, both in section or transverse and elevation. And this is the key one, really. 70% reduction in part count. So this one single component that we have eliminates all of those pots and various bits of tubing and so forth, the meccano that you normally see. And that results in this tremendous reduction in embodied CO2. And the secret weapon in the design is the material that's used to form this boom, which is a material called permally, which is of the same generation as bakelite. It's absolutely extraordinary. It used to be used for the same sort of applications that carbon fibre is used for today. It's a lightweight composite. It's beech laminate that's then pressure impregnated with resin. And it's still used actually for transformer housings in power stations. So you can mill it out, and it's got such kind of physical strength and electrical strength that it can contain the transformer. But it's also a fabulous structural material in its own right. You can see we've even got the old HS2 logo there. So we've been pursuing this particular angle for some time. Anyway, we think it nevertheless is a more appealing form, a more appealing design than the early that you typically see. And certainly it's a more compact footprint and quicker to install. Another bit for the Scottish Tourist Board, and sort of jumping around here. This is the northwest coast. This is Torridon, which is one of the, again, apart from the Cairngorms, probably the second most special part of the British Isles. Here we are looking at Slioch. This is a client meeting. They're two of our clients, Paul on the left, Will on the right, from the National Trust for Scotland. We're designing the National Trust's new ranger base and visitor centre in Torridon. And again, much like our studio, this building would not be what it is, or the proposal would not be what it is, were it not for the fact that we are involved in bridge design. I'm going to go quite quickly through the kind of plan organisation. You can see we've got the ranger base on the left, got public facilities on the right. There's quite a bit of complexity in this scheme in terms of how public access is maintained and arranged, which I won't go into. I'll sort of get to the headline, which is that this building is held off the ground. You can see this water channel just to the bottom of the plan there. This is subject to really quite extraordinary spate in spring as the snow melts. So we're lifting this building off the ground. It also serves to make the building visible from the main road to Kinlochleven, which runs just off the bottom edge of this screen. So otherwise the building would be sitting in a dip. We lift it up, it's visible to the public. In order to do that, we've somewhat of a conceit. We've looked at the landforms around, and like I say, this is Slioch, which is a remarkable looking mountain, and in particular note these kind of the triangular features in the face of the mountain. I'm no geographer. I think they're called spurs. Anyway, in lifting the building off the ground, we've looked at the building as a bridge, essentially. So this building is a truss that spans from a very limited number of points of support in the ground, and we're looking at the form of the truss as something that has an echo in that landform. So in this case, well, does anyone know what type of truss this is? It's a Baltimore truss, apparently, but it's a rather good-looking truss, we think. You can see here a physical model that we've just finished a couple of weeks ago, sitting in the Royal Scottish Academy. And the key here is that we're using timber from the National Trust's own estate, so it's Douglas fir that will be visually graded by engineers and then deployed for the building. And the secret of using that is keeping its feet dry. We're already doing that. We're lifting the building off the ground and keeping its head dry. So you can see the projecting eaves at the top. So it's an approach to detailing. There's a bit more to it than that, but it's an approach to detailing. It's all about preservation of the material more than anything. And that's where all of the kind of the architectural expression and the form of this structure comes from, the preservation of the material that it's built from. You know, people often turn their noses up at the use of spruce, for instance, but there are spruce buildings in Norway that have been standing for hundreds of years. It's all down to the detail. You can see in this image in particular how far the roof extends beyond the building line, which leads to a bridge. So same approach to weathering and protection of the timber has been used by Ezra and Maybach in Germany on this structure, which completed last year, just opened to the public a couple of weeks ago, which is as you can see, is a entirely timber primary structure, very simple structure, very simple bridge, but really rather beautiful. And the beauty of it comes from the manipulation of the design in order to protect that primary structural element from the elements, from the weather. So you can see you've got the waterproofing layer on the top. You can see how the side walls of the structure kind of canted inwards to keep it out of the rain as much as possible. And then the deck itself is providing weathering to the timber beneath it. And then pleased to say that this has led on to another commission elsewhere in Germany. That's actually a competition that we came second in, I think it was 2 years ago. But it's resurfaced as these things do. And so we're going to be progressing one of these bridges to completion later this year. Very nearly at the end now. So I've separated these three strands of economy, of purpose, economy of reaction, and economy of material as a way of discussing individual projects. Now, this is obviously a bit of a conceit, really. You could apply these categories to any of the projects that you've seen in any order, almost. So I want to close on a project where these aspects are almost in balance, at least in my mind. I'm not closing on this project, I'm closing on the next one. But Viaducts was the very first bridge design that I worked on, prior even to Swansea that Ian mentioned. This was while I was at Wilkinson Eyre. Very, very fresh-faced part one. Photograph is by Jim Eyre, actually, who's the partner in charge of this project, working with Arab, so with Ian Wilson and Angus Lowe, of course. And it was a great privilege as a young architect to be working on, or not even an architect rather, but as a young upstart to be working on a project such as this. I can't claim responsibility for very much of it, but the discussions with Angus about the portals at either end, you can see the roadway pops out of the mountainside and goes back into the mountainside at the other end. Again, like the sockets on Wendover Dean. I learned so much from Angus being involved in this project, and it's sort of stayed with me ever since. It's also worth saying that had this been built, this would have merited the word icon, which is not a word that I like particularly, but certainly I think this would have been up there with, the very greatest bridge designs in the world. And it's especially galling when you see what they've built in its place. And this is one of my most cherished photographs. Now, I've mentioned the names of a few of my mentors and heroes this evening, some of whom are in this room, but there are two more here, Angus Lowe and Ian Wilson. Now, I first worked with Angus and Ian on Viaducts, and then we were all together in the same team that designed Esperance, which you saw earlier with Martin, and also Somers Town, which is the bridge we're standing on in this image. Ian retired recently, and Angus, of course, is very, very sadly missed. Now, the genesis of this design precedes the project by about 10 years. It goes all the way back to a discussion that I had with Angus Lowe just shortly after I set up the practice about the design of a steel footbridge that would be, in his words, one of extreme simplicity. Using a single material, like I say, steel, following the simplest form of span, so a beam, but honed to its minimum, with the expression, the architectural expression provided by stiffeners, the necessary stiffeners to keep this thing stable, and an absolute focus on the finest, as in smallest, level of detail. Now you can see in this very early sketch, hopefully what I'm starting to describe. When we won the commission from Argent to design this bridge at King's Cross, it seemed the perfect opportunity to explore this concept. There's a total length, including the ramp, but the actual bridge was just shy of 40 meters, So if the beam was working hard enough, the topmost point would be coincident with where we wanted the parapet to be. And then there were various other considerations that were part of the brief to do with visibility over the canal, particularly for canal boats coming from the lock just to the north of the bridge, to be able to look down underneath the structure. Everything was pointing to a sort of form where structure is above deck and precisely of the nature that Angus and I had discussed all those years before. The bridge describes the bending moment. And we had a very supportive client. In fact, Argent seized upon the concept, which was one of several initially, before we did. You can see the final result there. So it's a very, very, like I said, 40 odd meters long, very, very slender. The top of the beam is only about 1 meter above deck level at the center point. The entire bridge is formed of steel, the same thickness as your thumb. And it's all down to the manipulation of the form of the structure in terms of the stiffeners. They are oriented to the canal, so they don't obscure the view from the canal lock down into the lower basin. And it remains probably my favourite bridge of all the bridges that we've worked on and completed in the practice, not least because of the involvement of Angus and all his support over the years, but also the synthesis of all the economies that I've spoken about coming together in this one structure. So to close, I'd say that we're all concerned with how to get to the other side, and hopefully through the discussion that I've just had given to you, and that we're hopefully about to have, I'd say it's not too grandiose to claim that bridge design shows one way of how it can be done. Thank you.